Hello, I'm Sean Lamp with Danfoss Drives North American Service Department. Today I'm going to go over how to analyze the data captured by NXS and NXP drives when they have a fault.
Please take a moment now to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
In this example, we will look at an AFE drive that was getting overcurrent trips. Our parameters, there aren't near as many parameters in an AFE drive as there is in some of the other drives. But we're going down to the fault history. We'd see we got overcurrent trips in the fault history happening at 3 years, 116 days, 12 hours, 49 minutes, 4 seconds. Now by default, the drive will put in a power on counter here. If you do set your drive with the real-time clock, it will put a real time in here. So if you are starting to troubleshoot something, it may not be a bad idea to go into the drive and set a real-time clock to the drives, and then it'll give you the exact time that the drive trips out on, as long as the drive doesn't lose that real-time clock.
NX series drives record the actual amount of time that the drive has been powered on. This can be shown from the keypad or an NCDrive as days, hours, minutes, and seconds. In addition to being able to record the total operating time, NCDrive allows a real-time clock to be set. This real-time clock will be set to the drive based upon the currently set time in the PC that the drive is connected to. To check or set the real-time clock in NCDrive, go to Tools, Options, Real-Time Clock. To check if the real-time clock is set in the drive, press Read Date and Time from Target. If the correct time and date is not shown here, press Set PC Date and Time to Target to set the drive to the PC's time and date. Press Read Date and Time from Target to confirm that the date and time have been set in the drive. In this example fault history log, we can see that the top 3 faults have a date and time listed for when they occurred, and the bottom 3 faults show only the operating days and hours. Note that the NX series drives do not contain a battery backup to retain the time and date information. In order to retain the correct time and date, the control unit must be continuously powered with 24 volts DC when mains power has been removed from the drive.
So when we're looking at this as being a regen drive, I said our output frequency will be the frequency of whatever our line coming in. So you can see these are all right around 60 hertz that we're connected to a 60 hertz line. The motor voltage is going to be pretty close to what the line voltage is. That it should be the same as what's coming in. Our current is going to be what we're putting back for current. Pulling in or putting back on current, it could be either direction that the current is going. Doesn't matter how much current or how much power and torque, whether we're running, what direction. I said the direction should always be kind of forward because you've got a certain rotation for the input. Their fault warning should always be at reference. You would hope that you're at that reference, and you can't be at a 0 speed. DC bus voltage, this will be, if the drive is running, this is going to be a little bit higher than what your normal voltage will support on the input, because you normally have the drive set for a certain amount of boost. This one is set for 110%, so that means we're going to boost the incoming voltage, the rated voltage, by 10%. So we're going to try and regulate the DC bus to that. So when it's running, the DC bus will be a bit higher. Temperature in the drive, and then it gives you the same subcodes as we had before, that this is a S1 overcurrent trip, so that would be a hardware overcurrent trip. It's in the power module, and drive thinks it's in the U phase. So let's take a look at the data log for that. So this is the data logger that's pulled out of there to see what it is. I said by time. The data logger, if you don't have the real-time clock set, unlike the service file, which puts it in years and days, the data logger does not. It just puts it in days and hours, minutes, and seconds. So you need to figure out the amount of days that are in there. So 365, you divide 1211 by 365 and see how many you get. So that'd be 3 years, and then whatever left over is your days. A lot of times the easiest way to look at that is to look at this time right here, the 12:49:04, and look for that time in the service file. So when we're looking for that, we look for that 12:49:04, and we'd say, yeah, it's this fault right here is what our data logger triggered on. So when we take a look at that, it's going to be a little bit more unique because this is an AFE drive. I didn't do any scaling of this beforehand, and just having this with the auto scale, I said you can see down on our currents down here, you can tell pretty easily normally which one is causing you the problem is that it's got a much higher scale because it's trying to auto scale it to fit onto the screen. Now visually, we like to see things all on the same scale, so we'll pick out the highest scale here and say, all right, we want to scale everything to about that scale. So we'll pick out 3000 and we'll just scale everything to 3000 so that we can see things evenly. So we'll just type in the scales. So we'll go minus 3000, minus 3000, minus 3000, 3000, 3000. So that rescaled all of our currents so that it doesn't quite look as near as much of a mess, and it puts them all on the same scale so that visually we can see that. So if we just want to take a look at what the currents normally look like, now you're going to see this doesn't look like the normal drive current that we would see, that this looks really jumbled up and kind of messy. Well, that's how an AFE runs when it's running, because it regulates the DC bus, so it's cutting current through the input reactors to regulate DC bus. So its current isn't kind of sinusoidal like you would see. Like this would be a normal INU drive. We're running the motor, and we take a look at the currents there, and you'd see they look all nice and sinusoidal, nice and even. Well, that's what current looks like when it's going through a motor, but that is not what current looks like when you're regenerating back onto the line or regulating DC bus. This doesn't necessarily have to be regenerating back on the line. This is regulating DC bus. If the drive wasn't running and we were pulling current through here with the AFE, this would look more like 6-pulse current, that you would see just the pulses there because it would be just a passive rectifier at that point. There would be some filtering with the sine filter if the sine filter's kicked in, but if the sine filter's not kicked in, then it would be just a normal rectifier with a 6-pulse current. So let's reset our scales and get it back where it was. So it's right in this area where we did have our fault, so we're going to take a look at this area and box out that area, and so we expand it out, and a lot of things happen in there, so let's get rid of some of the things here. So let's get rid of everything else except for UV and W and DC bus. All right, so DC bus stayed pretty much the same. You'd see the pink down there. I said it just kind of stayed about the same. There's nothing going on there. The other currents were kind of about the same, and as we get, you just see that the U current, so the fault history was correct. It was U, that was the one that spiked on us, and it just spiked up, stayed spiked for a little bit, and came back down again. Now this is pretty obvious false current. This won't really happen, especially on a regen drive going out there where we just got just a massive spike of current, and then it just all of a sudden just dies. So this is false current on the U phase feeding into the drive. And again, the false current generally on NX drives is coming from the current measurement boards. Again, can't guarantee that because current does feed through almost every circuit board in the drive. That it starts out in the IGBTs, that's where the current sensors are on the bigger drives, as the current sensors are in the IGBTs. It feeds up through the current measurement boards. From the current measurement boards, it goes to the gate driver board. Then the gate driver board, it goes to the ASIC card, where the ASIC changes it from analog to digital, takes it up to the bus adapter, and then the bus adapter changes it back from digital to analog and feeds it up to the control module. So it goes through almost every circuit board in there. It's just this type of failure is almost always in the current measurement card where it spikes up. So on something like this, we'd say, yep, we want to go and change out the current measurement card.
Thank you for viewing. We hope this information has been helpful. Danfoss Drives can provide additional technical support, parts information or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS, or 1-888-326-3677, or contact us by using one of the listed email addresses. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com.